Start.
So this is the presentation for our final project in the WES 237A class. The team name is DMIPS, Prasanta Dimitru. And the topic is a smart doorbell. The equipment we use for the project is a BeagleBone Black, a camera, 2 XB radios, a pair of USB to serial cables, and for software we use the OpenCV libraries for taking picture and the Python library as well to convert an image to a string and then back to an image, proper image file. The goals for this project is to trigger a camera based on an input from a radar, which responds to a proximity event, to obtain an image in BeagleBone Black using the OpenCV library, establish a connection from a BeagleBone Black to a remote laptop via 2 ZigBee radios, to read the image from the BeagleBone created by the camera and convert it to a string, and transfer the image using XB from BeagleBone Black to a target display device. The three important pieces of hardware that we use are a webcam, ZigBee radios, a pair of them, and the BeagleBone Black. This is the block diagram of our setup for the smart doorbell. We have an ultrasonic sensor which acts as a radar and monitors for a proximity event, essentially somebody coming close to a camera. When the proximity event is observed, the radar sends a signal essentially over a serial port to embed, and the embed then conveys that the information from the radar, essentially range and azimuth, although we don't use the numbers per se, but we just look for the presence of that flag. And the embed microcontroller sends the flag to the BeagleBone Black, in particular to Python script on the BeagleBone Black. This the Python script, upon receiving this flag from the embed over the serial interface, sends a trigger to essentially creates a trigger to take a picture, and the camera saves the image file locally on the BeagleBone Black. Then the same script also takes the image file and converts it to a string using a special library from Python, which uses a 64 size alphabet and is based on a standard. After the file is converted to a string of characters, the characters are written to the serial port and then sent over ZigBee. On the left we have the coordinator, and on the right we have the router. So after the string is sent over the air and the router receives it, it forwards the string, or essentially Python looks for that port, essentially using threads to not interrupt or interfere much with the main main program. And once the Python script on the remote laptop receives through the serial port the string, it converts it back to a proper image file, and then a library function from Python from OpenCV shows that displays that image. This is a flowchart for what we described. On the top left we see we indicate that the radar communicates over serial to send the flag to the BeagleBone Black, and when the flag is received, the Python script on the BeagleBone monitors that serial port continuously as a thread And when the flag appears on the serial port and the if condition is checked, then the Python code triggers a picture from the camera. The camera takes the picture, saves it locally as a file, and then converts it to a string, then sends the string over a serial port to a ZigBee radio. On the left we have the coordinator, and on the right the router. On the right side, when the serial port receives the string, the Python script on the remote laptop essentially takes the string, reconverts it to a proper image file, and then using this CV2 image show library method, it displays the file, which is again recompiled from the string received over the ZigBees. Here we have some snippets of the script that perform the main functions described. We see that we open a window called image. We define a function to essentially cause the camera to take a picture. There is a loop to discard the first 30 frames approximately. Then a print message, and essentially after we discard the first 30 leading frames, we actually get the image, the frame we want to keep, using the get image into the image called camera capture. Then we also it can be shown on the BeagleBone side, and also we can obtain information about the file itself, and then the camera is deleted. On the next slide we show the relevant snippet of a Python script that is responsible for taking the image file and converting it to a string using this standard function, encoding function, base64. Basically read the file and create the string. This string is then being sent over the air over the ZigBees, and we have a separate clip for that. And then on the remote side, the laptop receives that string, opens it, and then writes into a file the decoded version of the string, essentially a new image reconstructed from the string characters.
Okay. Now we'll give the display as possible. Okay, let me go over the test setup now. This is the sensor, which basically we configure the sensor so that it detects the face when the individual comes within 30 centimeter distance, and we have ZigBee to both the ZigBees. One ZigBee is the router, one ZigBee is the configurator, so coordinator, and this is the camera where it's configured. And as soon as this is now Dumitru is around 50 centimeter, more than 50 centimeter. Once Dumitru comes within 30 centimeter range, the camera will get automatically triggered, and the program in that particular PC will take the picture, make it a string, send to the target PC. Target PC is this one. Okay, so Dumitru, why don't you move to 30 centimeter and I will take the picture of camera. Okay.
So you see now I haven't got it close.
Yeah, Dumitru is getting close. Now we can clearly show the camera. Yeah, camera is became blue now. So picture has been taken, and it automatically will send to the target PC. We can clearly see in the target we have the strings which is there. Now we have to run a script which will convert this strings to the image. Now Dumitru is saying hello. So exactly the image what we did. From there it got copied here. This was the originator and this is the target. Thank you.